See if you can visualize this one. When a cube is cut into two pieces with a single plane cut, two polyhedra are obtained. Which of these polyhedra cannot be obtained in this way? Well, the easiest way to do this one, I think, is to find all of the ones that can be obtained. So the one that jumped out at me first was a four-faced polyhedron. That just means a 3D shape with flat sides. And if you cut through like this with a triangle, you'll get a pyramid on one side with a triangular base. And so that would have four faces. Now, if you think about what you're left with once you've cut off that pyramid, you can also see that the rest of the cube will still have six faces with a bit chopped off, and it will now have this extra triangular face on it. So that one would be a polyhedron with 7 faces. To get 6 faces, I think, is quite easy because you could just slice the cube in half and you're left with a cuboid which also has 6 faces. So we've just got 5 or 8 to choose from, and then we notice we can just push the edge of the cuboid that we've just had on the top there to be in line with the edge of the cube, and that will leave us with this wedge shape that would have just 5 faces because we've just removed that top face from the cuboid essentially. So we found 4, 5, 6 and 7. We haven't found one with 8. It would be a bit harder to justify absolutely why that's not possible, but a maths challenge question here, we know that E must be the answer at this point, and so we can happily move on.